Diagnostic Manager is, in essence, generally speaking, an agentless tool. And I say generally speaking because there is one particular component, it's an optional component that you can install to the SharePoint farm to give you a little bit of advanced data. We'll talk about it at the end. But in general, we've got an application server of our choice hosting a collection service. It's a normal Windows service, a console UI that you just looked at, the app that we actually interface with, and then a repository database that stores all of that collected metric data for the two farms. That all those alerts and data points you saw were stored in a repository on my SQL server. So these can all be on one machine. This can be totally distributed if you like. You can have a dedicated SQL server, dedicated app server, and then dedicated workstations in plural, multiple consoles out in different user workstations to give multiple people access to the same data. But yeah, so this backend is installed and distributed as you like. And then what happens is this collection service is doing remote WMI calls to these various servers in our farm. So the first thing that happens is this tool identifies the farm and then quote-unquote discovers the topology. In essence, queries the config database and learns what servers live where. And then he starts making these remote WMI calls to them to collect this OS metric and SharePoint WMI metric data. And there's some SQL queries that go out to the SQL servers to learn information from the sys databases table and et cetera, to get information about the SQL server. And then also directly to the databases themselves to get some of that sizing information and file information you saw on the SQL server view. But that's really it. We're just doing these remote calls. So all this is standard out-of-the-box kind of Windows functionality. We're just leveraging it from that collection service, containing it all, baking it on our side, and then firing alerts and notifications based on the information we get back per configurations we make in the tool. And again, we'll go through all of that in our next session. So one by one, we've got this management console, which can be installed on multiple machines, as I mentioned. And then it empowers each administrator to use that console to help manage their portion of the farm, for instance. Or if you need to have multiple people simultaneously having access to view and read and see stuff over time, we can certainly do that. So all those multiple consoles connect back to the same back-end collection service per our previous slide. Let's say I had a console here, 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 here. They're all connecting back to this guy and reading collected data from this guy, right? So we've got the central back-end piece and multiple consoles who read from them. So this console can deploy to any Windows OS. I think going back to about XP, if I'm not mistaken. We may no longer support XP, so don't hold me to that. But all the way up to 2012, obviously. So this is a centralized intuitive interface that lets us configure Diagnostic Manager at an administrative level. Lets us select SharePoint farms to collect data from, as well as pages to monitor. It lets us review collected data and analyze our SharePoint deployment. And just as we've seen in my little demo earlier, then each console reads data from that repository database to be shown graphically, right? This is the ninth point, that's the last bullet point. So this last point is, I think it's kind of key because it's important to understand that in addition to connecting to this collection service, we are making a proper direct read from our repository database to get all those data points in the console. So each data point we see in the console represents a record in our repository. Moving along, the collection service itself, this is the workhorse, so to speak. So he's the guy who's doing all the work. He's collecting the data from the SharePoint farm. He can run on any workstation, and he has to be running in order to execute jobs. And by jobs, I mean those daily, really, I think by default we collect every 6 minutes. So every 6 minutes he needs to be on to run those collections. So he collects all that data and then records it into the repository database. And that's metric information and alert statuses, etc. I mean, there's more than that. Your enterprise network can have multiple collection services installed, but the management console can only contact a single service at a time. What this means is that if you've got a huge enterprise with 20 farms, it may make sense for you to distribute the load between two separate installations of VM. So that, again, if we go back to that earlier slide, one collection service collecting at all the servers in the farm. Now, if you're managing 10 farms, this could really stack up, right? And in turn, this repository could really grow. So depending on the size of your enterprise, it might make sense to distribute that load to another collection service, just depending on how things are in your environment, how resources are allocated. We can certainly do that. It's just important to note that no console can connect to both collection services at one time. And additionally, each collection service will have to have its own repository database to store data to. This little note here, if the collection service encounters errors, it automatically logs into the Windows event logs, and then we can use Event Viewer to review those errors. Moving along, a little bit about TCP IP ports. So we're making a lot of remote connections, right? So what do we need to have open to get to those servers, yada, yada, yada. So the console uses a couple of ports, 5292 and 94, to communicate with our service, right? So we have to allow outbound communications on those ports from the computer that hosts a management console to the computer that hosts the collection service. And then we have to allow inbound communications on 92, 94 on the computer that hosts the collection service. So in essence, we've got two separate one-way communications. Collection service sends info to console. Console receives on 92 and 93. Console sends information to service. Service receives on 92 and 94. This can be a real confusion point, and it only really matters if you've got a distributed installation, right? If you've got consoles on other servers out there and on separate workstations. But again, rule of thumb, any console machine, you've got to open up 92 and 93. Any service machine, you got to open up 92 and 94. The collection service itself uses the Windows Management Interface. I think that interface is wrong. It should be Windows Management Instrumentation, I believe, to collect information about the servers in monitored SharePoint farms. So if we want to collect information about servers, we have to allow communications from the computer that hosts the collection service to the servers in the monitored SharePoint farms over these ports. Now these ports, notice I didn't indicate ports, right? These ports, I mean, remote WMI connectivity is a concept in and of itself, right? So we rely on the ability to make remote WMI connections. Windows has tons of literature and articles on the subject of allowing remote WMI incoming connections. The reason these ports is left ambiguous this way is that we can define those separately via Microsoft best practices. I think by default they're dynamically assigned in a range, but at the end of the day, the point is, if you're having trouble connecting to your server endpoints, it's likely due to the fact that you don't have the servers configured to allow incoming WMI connections. And again, we've got a couple of KB articles in our internal knowledge base that reference some Microsoft documentation on the subject of allowing remote incoming WMI connections. So don't let that daunt you. If you run into issues when you install and you can't hit your servers, it's really usually a pretty quick and easy fix just to get those servers configured to allow those incoming connections. Typically you see that on SQL servers, because I find that SQL servers are generally more locked down than other servers in the farm. So, and then finally, when the collection service performs page availability, load time, or component analysis tests on pages, it's just going to use whatever port is specified in the URLs you supply. And if no support is specified, the default web server port is used. Otherwise, these are just straight up HTTP requests, right? All right, moving on. The repository database. This guy stores all the data that we've collected from the SharePoint deployment, and we use our management console, as I mentioned before, to review that data. So whenever we install, we're going to specify what Microsoft SQL Server database instance we want to host this database on. It can literally be any SQL Server instance of your choice. It doesn't necessarily have to be your SharePoint SQL Server, but it can. But again, like I mentioned earlier, I mean, we can distribute this installation as much or as little as we like, right? I mean, we can have a console separate from the service, separate from the database, or we can have them all hosted on one machine, such as it is in my environment. So we're storing configuration info, statistical and collection service collected data. This includes information about the topology, what servers live where do they exist. This includes collected metrics, what was the memory on the 12th of April at so-and-so p.m. and then every 6 minutes thereafter. This includes grooming configurations, how often do I want to delete data out of this database and how old do I want to keep it. And then the same goes for alerting configurations. When should I alert on a warning for max memory? Who should get notified? All that stuff is stored in our repository. So the repository is pretty important in regard to the infrastructure and the architecture. And then again, each collection service uses a unique repository. So not too much to be said about the DB other than he's important, he stores all the data, right? So we can groom it, and as you could probably imagine, the question of how big should I, what size should I count for my repository is a pretty prevalent question. It's a tough one to answer because obviously there's a lot of variability in terms of how large your environment could be, and of course what all you're collecting metric data on. But in general, and this is a very, very general, per server we could expect 1 to 3 gigs of data per year. So multiply that by 5 for a 5-server farm, et cetera, et cetera. That's a very generic baseline. Content is king. So the more multimedia, obviously the more data we're going to, or the more servers in the farm, the more data we're going to be pulling back, the more metric data we're collecting, because we can control what we do and don't collect in VM. Obviously that'll have an effect too. We actually have a pretty nice little white paper on the subject of repository sizing planning. So if you have further questions about that, we can certainly get that out to you. But in general, 1 to 3 or 5 gigabytes per server per year. Which brings us to the black sheep of the family, the component analysis solution. I call him the black sheep because he's, what I alluded to earlier, the only component that would actually get installed to the farm if you choose to use it. 9 times out of 10, you'll probably choose to use it, but it is an optional component. What it gives us is some advanced information. It gives us the views I showed you earlier in the tool that told us which web parts were performing slowly, which HTML controls, which web controls were performing slowly. This solution is responsible for that. And it's literally a farm solution. So it helps the collection service gather data about page load times, solution load times, ULS log entries, and other information. And we install that solution on a web front end in the farm, and as with any other solution, it automatically replicates to the other WAPs in the farm. So as a SharePoint admin, if you're familiar with the idea of deploying solutions to your farm, it's no different for us. This is the WSP. We package it in the installation directories for the tool. We also have a self-extractor installation utility to install it kind of automatically or programmatically. But yeah, otherwise you can take that at WSP and use STS ADM or PowerShell, whatever your preference, to load it into your solution store and then deploy it from there. And obviously, if we want to collect this information for a page, the solution would need to be deployed to the web app hosting that page. So hopefully that'll make sense to those of you who are familiar with solutions. But yes, this is a farm solution. It does get installed to the farm. This is the only quote-unquote agent involved in this tool. But again, totally optional. If you don't care about component render times or ULS log entries, then you don't even have to install this component. We can get everything else we need by normal means. But if you're interested in that deep dive information, and again, likely you are, then you'll need to deploy this solution to your farm so that we can leverage it to get that deep dive data. It's basically a hook for our collection service to get deep nuts and bolts info from the farm that we can't get by normal means. So I think that's basically it in terms of what I have prepared.